Welcome to my talk, Retiring the Singleton Pattern, Concrete Suggestions for What to Use Instead. My name's Pete Muldoon, and I'm a software engineer at Bloomberg in New York. And I've been there 5 years, and before that I did about 21 years of consulting, seeing a lot of different firms and what went on in them. So the reason I came across what inspired me to write this talk was not that long ago, it was earlier this year, I was looking at email, and when things are put in for code review, we use a JIRA system. There's a title, and it's sent out to everybody who's part of that repository. And I seen the word singleton in the title as I was scrolling down my email, and I was like, whoa, what's a singleton doing here? Someone said, I've converted this to a singleton to make it more efficient. And I know who the guy was, so I went over to his desk and I said, what are you doing writing singletons in this day and age? And he kind of looked like he'd been caught with his hand in the cookie jar. I was like, look, I just had to get this thing done. You don't understand the code I'm in. It's not possible to do it another way. So that was one event that happened. And then what happened within the next week, and that's an older code base, so you could maybe be forgiven. In a brand new code base, I was looking, and I seen that I actually work in, and I seen one of my colleagues writing a singleton. I was just walking by her desk, and I seen singleton on a code line. And that kind of thing, kind of subconsciously, it was like, something's wrong. What did I just see? And I said, why are you writing a singleton in brand new code? Brand new, was it C++ 11, 14? I was like, why are you writing a singleton? I have to use a singleton. There's no other way around it. I have legacy code tapping into the new code base, and the only way I can get information in is via singleton. So they were the two pieces. I said, please let me do this, and I'll come back with you and show you how you can't do it with a singleton. And that's how this talk kind of grew. But once I took this on, I went out and said, this should be a solved problem. There should be plenty of solutions out there. And I went out and I came across one of the Google talks, which was about what's bad about singletons. And it was a pretty good talk at showing the hidden action that happens behind the scenes. But at the end, when someone said, well, what should I use when I'm kind of stuck? Guy had a widget for putting messages on the screen. He said, I can't be passing that around to every function, and it's just so darn handy. And his answer was kind of restructure your whole code base, which is really not very good advice. And the way he seemed to restructure it was using a factory class, which to me sounded a lot like a singleton. So, these days people don't dare put the word singleton in their classes. They call them registries or factories or this kind of thing. But really what it is just a global place you can reach out and touch someone. So after that, I went and I looked around, and I seen this on, and this is really where I got the title of my talk from. Someone said, what is so bad about singletons? And it was, I guess, someone who was newer to the coding game, and a lot of people were like, it's bad, it's terrible, don't do it, and didn't really say much about why it was bad. And the comment that one person said, the worst part of this whole topic is that people who hate singletons rarely give you a concrete example of what to use instead. Now, I don't think restructure your code base is a practical way of doing it. So I think what we really meant to say is, give me a practical way of limiting the damage that singletons have in an already existing code base. Okay? So, I'll just give a brief talk outline. We're going to examine the singleton pattern briefly, as, it's like, what is so bad about them? And then we'll talk about how we refactor singletons out of example functions. One where we don't have the callers of the functions that are using this singleton to have to modify their code, or even recompile it. And then when I did this myself, I ran into other problems, which became, and this is what we deal with when you don't have copyable types because the copy constructor is private or removed. Delayed construction, the phased introduction of the replacement pattern. So when you have 1,000 files and you want to touch a piece of them, but the singleton is all through the code base. How do you prevent having to touch the whole code base? The initialization order of interdependent singletons. So this is where in the Google Clean Code talk, he talked about he had a credit card singleton. And when he tried to use it, he got a core dump because you have to initialize a credit card processor singleton. There's nothing telling you from looking at any of the header files that's what's needed. And then that needed, I think, some sort of flow control singleton, which needed a database singleton. So there's a whole lot of initialization that happens. So singletons reach over to other singletons, and you've no idea what your dependencies are. And it's easy to use them wrong because you need to put in your main specific order of initialization. So we're going to try and deal with that as well. And then at the end, we'll review and I'll take questions. So looking at the classic singleton, in case you've never seen it, this is an example of it. And the notable characteristics of what makes a singleton is there is only a single global instance of this type. And that comes with the instance function. Now, this isn't set up for multi-threading. We'll get to that a little later. This is just to keep it on a slide. So what happens here is you see the constructors, the assignment operators, the copy constructors, they're all private. They can't be used. So you cannot create one on your own. The only way of getting it is through the instance function, which is globally accessible, meaning you can reach out from anywhere, and this is what makes it have hidden dependencies. The initialization of this is also out of your control. You can't say, I want to set it up this way or set it up that way. You get one, and that's all you have. And because you only have one, the state is tied to the program lifetime, not to an object lifetime. So it makes it hard to test. So these are the characteristics. And the drawbacks of a singleton mirror very closely the characteristics of it, meaning you have this one globally accessible instance. So they act as hidden dependencies in function. While you look at header files, you have no idea there's a singleton in there. Because of that, you have no dependency injection. And because of that, you can't put a mock or a stub in to help you do unit testing. So these functions become opaque to unit testing. As I said before, the initialization is out of your control. You're given it. You usually call initialization functions somewhere in your main just to tell it to get up and running, sometimes with some parameters, and that's it. Multiple runs can yield different results because, again, you can't create an instance, throw it away, create a new instance, and throw it away. All right, you have to use the same instance, and it has type, or it has state that's tied to its whole lifetime. What exacerbates this is that the groups need, usually singletons rely on other singletons, and there's this hidden chain of initialization calls that are needed. So they're easy to use incorrectly. So reasons for using it anyway, and these are some of the reasons I got back when I kind of jumped on colleagues for bringing in singletons. Internally, if you're in a large code base and you're at the bottom of a 15 or 20 stack function call, you can't, it's almost impractical for you to go and say, I want you to go and add this parameter to every other function that calls this. All right. The speaker's going to get it. All right, as I was saying, when it's internally in the code base, it's impractical for you to go and say, I have to touch a major part of the code base, passing this parameter all the way down into these bottom low-level functions. And that's usually due to code not being decoupled properly. So you're in the bottom of a function and you have to save it to a database, put it in a cache, send it out on some kind of broadcast. When externally the reasons why people use them is because I have a legacy API and I have people who've been calling this function for a long, long time, and they will not take on a new function. They don't have the time, don't have the resources, or the people who wrote the function are all long gone or dead and buried, and no one wants to touch this code base. So I can't just say I'm changing my code and you all have to follow suit. And again, the one I only create one of them and reuse it. I don't think you really need a singleton for that. The point of the singleton, when it was first came up within the design patterns, which gave it a lot of legitimacy, was the point of the singleton should not be to grant global access to a type and make it an easy global grab bag. It's to control the instantiation of a particular type, but it's normally used just to get a handy grab bag. So a question. Here is part of our I/O stream, and we have C in, C out, C error, C log, whatever. Who here thinks C in and C out are singletons? Okay. Who here thinks they're not singletons? All right. Most people seem to not know. All right. Let me try another question. So I have this external int that has a throttle limit. I'm going to use it somehow to say how many can come in. And it's set at a fixed value, and I just grab it in functions. Is this a singleton throttle limit? Who thinks it is? Okay. I won't say who it isn't. And then I have another function called getThreadLimit. Somehow I want to limit the amount of threads I spawn. And I take that at the very beginning, the first time it's called, I set it and I never change it. Is getThreadLimit returning me a singleton? Anyone think yes? All right, not many hands, but I don't know many would say no. So none of these are singletons, right? Because a singleton is a type with only one instance. When I return an int, it can be, I can make any amount of ints I want, right? All of I have here is, for instance, in throttle limit, it's just a defined variable. It's not a singleton. I mean, I can create, different ints to do different things. And I only make this point because when we get down further, people will confuse a single instance as a singleton. A single instance of an int or a class is not a singleton. It's only when you can only have one and you can't create it on your own. So let's get to it. This is a piece of code that's using a singleton, and it was one of the first singletons I was getting rid of was something along these lines where I have a function that takes a data record, it's packed full of data. I don't really care where it came from, and it's either down below a big stack of function calls, or I have people from other groups linking in and calling this function. So what does I have is I have a request object, and I'm going to take the data from the data record. I'm going to look up, transform it. Maybe I go out and get some things, concatenate it, whatever. I make new data, and I put it into the request object. And that request calls the singleton and sends it out to whoever needs to get it. And it comes, I get a return code or something back. All right. This function is not testable right now. I can't mock these things. There's no dependency injection. I can't see what goes into request or what comes out of it. And this is one of the major problems you have. So let's say I'm going to remove the singleton. I want to get rid of this ability, and I have to have some basic requirements, and refactoring the whole code base is not going to be one of them. So the new function must be source compatible. What that means is any of the existing callers, whether they're internal or external, will not have to change their code. It will be transparent. I would like to express the involvement of an outside agency. I'd like to be able, when I look at a header file, for people to be able to see, look, there is something sending this out. And because of that, I will have dependency injection, which is a big win because I want to be able to test this. I want to take a function that wasn't testable and make it testable. So how am I going to do it? Well, I'll take first crack at it. So here what I've done is I've said, okay, let me go into the header file and drop the singleton in as an explicit parameter. And I'll give it a default value. So any of the people who are calling these functions, any of the callers, can still get away with calling it with a single value. Okay. However, we haven't really met the requirements. It is source compatible. It does show you we're having something that's doing the sending, but we don't have any dependency injection for testing purposes, and that's one of the big deals of getting this thing done. So what I'm going to do is I'm going to go back to my singleton class, where it has that init function that's called in main. I'm going to put all the init into the constructor. But I'm going to give it a constructor that doesn't take any values, which is going to set it up the way it would have been done if it was called initialization from main. I'm also going to take all that code that was in the send of the singleton and plug it in here as the send member function. So I'll basically have lifted two pieces of code and just put them into a regular class. Okay, this is just an example. I put a raw client in there because I'm going to make it so I can't copy it. But what I have now on this is I now have control of creating as many instances of this as I want. And I'm going to get control of how I delegate that send function as used. So it's going to give me testing later on. So I'm also going to need this. And this is for the legacy callers of my function. I need some way to inject information for people who will not change and inject it themselves. If someone comes along to make new code, I expect them to put their own COM wrapper in. But for now, anyone who doesn't have it can use a single parameter, and I'm going to inject it using this. Does anyone think this service is a singleton? All right, good answer. All right, I can make as many of them as I want. So now I'll go back to my original function. In the header file, I'm going to drop this COM wrapper reference in, and I'm going to give it the static initialized version I had in the header file. This is going to allow me now to show that, look, there's a comms wrapper that's taking care of the sending, and it's going to still allow legacy callers to call it with just the data, because I'm going to pull out I'm going to call it a well-defined global right now to inject the information. Can we now test this with dependency injection? Well, not really, because I got to put a comms wrapper in, which will do all the actual sending. So what I'm going to have to do is go back here and just add a virtual. Right? What this is going to do is give me runtime dispatch. Now, anything that inherits from this, which is what my testing classes are going to do, will be able to be as a drop-in replacement on the test. And as you see, here's the function now, so it's all going to work. So now I want to do some testing of my function that was previously opaque. So if I'm going to do it by hand, I'll take the COM wrapper function and I'm going to derive off it. And I'm going to give it a send function, which is going to override the, if this was C++11, you would have an override in there. So I'm going to override the send function. And here, as you see, I'm just going to take some reference to a request in the constructor, and I'm going to copy it over if anyone sends. This is going to allow me to grab the request out of that function and take a look at it afterwards. So now in my test data function, I have this data record. I put an ID of, I don't know, 999. I'll put whatever other values I want to put in there. And then I'm going to take the COM tester client and initialize it with this request. Once I'm in there, I'm going to call the send data. And what happens is underneath the send data is just going to call the send on my COM tester, which means I get a copy of this data back. So now I can now check what's coming out of my function. And here I just check the sender ID, but I could validate all the values that are in there. So, clear?
Not super. Not super. Could you? No, I'll ask a question at the end.
All right. There's slide numbers here, so you can always take me to task at the end. All right. Where I am, we use Google Tests. So we just, instead of doing it by longhand, I can just mock out the method. Say, I have a method taking one parameter, it takes a const request and returns a response. Then in my actual testing, I'll create this client, and again, I'll set my expectations where I'll say I expect this thing to be called once, and whatever you get called, I want you to save that argument into my request here. And once that's done, again, I'll call the send data, and I can assert that various values are correct. So what I've done now is I've made a function that was opaque to testing. It's now testable. But that was in more of a pre-C++11 way of doing things. We can do type erasure if you don't like inheritance and say I'm putting vtables in where I don't like having vtables. We can create an std function that takes a request, returns a response. I'm going to have that func be, again, default of the service COM that's been set up as the well-defined global for dependency injection. And when that happens, the whole thing just works, right? It's going to use type erasure and call that function. There is a potential problem here in that a copy has been produced. So when we say this function is equal to this callable object, it copies the callable inside of it. If your callable object has anything that can't be copied, you're in trouble. Okay, if you have a unique pointer in there, you have a socket, anything which has private constructors in there. So how do we get around that? Well, right, std gives us the std ref. That's going to give us a reference semantic, meaning that we don't actually do copies. We just use the references inside. And now what I have is a testable version that's done in modern C++. Though some might argue you probably wouldn't have a lot of singletons running around in modern C++. I don't know if I'd agree with that. So there's something else that is on the horizon. A guy, Vittorio, has this thing called a function reference, which is like an std function, except instead of copying the callable inside of it, it just points out to the callable. In this case, it does the reference for you, so you can just let it rip the way it is up here. And because we're now using type erasure, we don't have a send. We're just using the parens operator. So we have a parens operator here. We don't need any virtual function because we're dropping it into a function or a function ref. So this will all just work. Now again, if I want to mock this thing out, I'll just dispatch it from paren to a mock method. I don't believe you can mock the parens in Google Test. And once that's done, I'll just do the same thing as before. I'll create that client. I'll create the data record. I'll put some data in it. Then I'll have my request. The request gets copied out. And at the end, I can validate. One thing to note is Google Mock will not let you copy either. So even if you had something inside your class that everything was copyable, Google Mock will complain. You will have to use reference semantics on it. So here's what we did originally. So this is what I call API compatible. All your clients will have to recompile, but once they do, that's all they have to do. All right. But what happens if we're shipping libraries or we're sending libraries out? If I change it from a single parameter to 2 parameters with a default, I've changed the ABI. So people will have to recompile. So how do we get around this? This is what I was saying. All right, so it's source compatible, but requires a recompile. Shared libraries, the function signatures can't change. So what I'm going to do is keep the original signature function and just have it as a dispatch. This will be in the CPP file, not in the header file. And what happens now is when you call the single version of the function, the send data is going to call the two parameter version, and again stick in that global dependency injection of information for anything that doesn't want to use the 2 parameter. But what we've done here, we've done quite a good thing here, I would say a somewhat marvelous thing, is the send data original function is now just a dispatching function. There's no intelligence, there's nothing in it other than putting in some information. All the operations, and this could run to 1,000 lines of code, are now in this 2 parameter send function. And this original signature you would start marking as deprecated, and you'll want people to use this. But in the meantime, all the nastiness is held in just a dispatch function. So going back, here's what we were using to inject the information for clients who want to use the original single parameter function. But this is a potential problem, and I actually ran into this problem where I had created this wrapper class. It created at run before main ran, and it opened a few file descriptors. And then the process forks for the Bloomberg terminal. And I got a problem ticket coming in, and hey, we've got tons of file descriptors open that we didn't used to have. What's going on? Can you fix that? And that's because when I do this, it's done before main runs. And sometimes that's not going to work. Right? There may be static dependencies across various singletons. They have to be initialized in a certain order. That's going to cause you problems. You have to do some setup before the code is usable. So we need to delay the creation now without changing the caller's perspective of what's going on. We need to change this so that we have lazy initialization. And again, that is a well-solved problem. If I'm pre-C++11, here's how I would do it. I'll just have a pointer to my wrapper class, a static pointer, and then I have a getDefaultComs function. Anyone know what compiler do once does? It does the thing once and once only when you're multi-threaded. Now, the reason I have that in here is because pre-C++11, it was compiler specific how you do the double check locking. So you can drop a mutex in there if you want, but that's seen as something that is expensive to do. So they come up with a double check locking where you don't have to hit the mutex all the time. In Bloomberg, it's a lot more hieroglyphical, so I just changed it to a compiler do once. So this just means that the first guy to call it will create the first com wrapper, and after that, everyone else will just get it back. Now, who here thinks this is a singleton? Returning a singleton? Now we got one guy, two guys, all right, three guys. All right, four guys. So again, and I don't want to labor this point, but it is crucial to understand that com wrapper is not a singleton. Com wrapper I can create however I want and many I want. All I have is a function returning me a certain instance of a com wrapper. Think of it going back to you have a function that returns you that int. The int itself is not a single, it's just a single value of something. All right, and I need this single value to inject information for people who won't use my new two-parameter function. So now, if I'm in modern C++, they got around and they solved this problem for lazy initialization. So you can do it this way now. You don't have to get into compiler specific or whatever. The compiler automatically takes this, as will compilers previous to this. If you're using GCC, they actually already had implemented something like this. But again, we're not returning a singleton. But now in my dispatch function, I'm going to inject the information using this default function, which means I'll get delayed initialization. So everything will run only when the first guy calls it. So if no one ever called it, actually nothing would get created. Now, here is one of the big problems that you find is that here I am, I've phased out a singleton, and I'm like, this is great. And then somewhere else in the code, and maybe 150 places in this code, there's other code using this singleton. What am I going to do? I certainly don't want to touch 150 files when I've maybe been in 3 or 4 files, and I'm doing I want to do a relatively modest change. But I do want to make sure the changes I did are tested. So I have now got this nice send data function that's nice and testable, but I have a sendx that's using this com singleton. So again, I looked around me and I'd seen where people had said, you know what, they created a wrapper, and then the wrapper just called the singleton function, which I thought really didn't get you far. You replaced it with a class you could create multiple instances of, but then you just pass a singleton back. And they said, well, once I get all 150 instances of this replaced in the code base, I'll change it out of the function and I'll make it non-singleton. I checked it with the guy 6 months later. He still hasn't got back to it. All right. So here's what I want to do. If I go back and I look at my singleton, I see that, and this is now a thread-aware version, people call the instance function, and it returns this singleton, and it has this send on it. And elsewhere, here's how people call it, right? You call the static instance function, and then you call a function on it. What if I change the singleton to do this? So I've got rid of the instance variable. I leave it as singletonous as it was before, except now I'm returning an instance of my com wrapper, and not just an instance, but a well-known instance. Right? If it was something like comms, maybe you don't need to do something like this. You say, well, I open 2 connections instead of 1, and maybe that's okay. But if it's a cache and everybody has to use the same, this is the way you go. So now where people are using that same com singleton instance call, it all just works. So let's go back to the original code. Whether I call the getDefaultComs, which does the lazy initialization, in the send data function, or it happens in the send x data function over here, one of them will call it first, and everyone will get that same instance back. And this way you can do a phased introduction. Now the send x is not callable, it's not dependency injected, I can't test it, but I can get to that sometime later. And that's really a key part, because the heavy lifting of changing too much code makes people balk at what they're doing. One small caveat, as long as someone is not naming the singleton, so as long as someone isn't saying da-da-da, com singleton, my instance equals instance, and carrying around, it'll all work. But I have never seen a singleton called any other way than this way. And I've been around a long time. So, how am I doing for time?
Halfway, I think.
Halfway? Okay, I'm on track. All right, so now let's talk about initialization dependencies. We've talked about having that instance and getting the global injection of information. But let's go back to something that is really common. When you see a singleton in a code base, believe you me, it's not the only one in there. Right? There's a lot of them running around. You just peel back the covers. And your best place to find singleton dependencies is look inside a singleton. They usually talk to others. So let's say I have a com singleton. And that talks to the cache, gets some information out of the cache for what it's sending. But the cache singleton talks to a database singleton, because it's got to save off its persistence data. What am I going to do as far as, so I go and I say, I want to replace these all with wrappers. How do I make this thing just work? Take away all this. I have to initialize the database first, then the cache, then the comms, do that all in main, and then somewhere miles away, my function just starts working. So the DB wrapper had no dependencies, right? It was at the top, or should I say at the end of that chain. So the cache wrapper needs a database wrapper. All right? So let me be explicit about that. I'm going to say when I have a cache wrapper, the only constructor I have is one that takes the database wrapper, and I keep a reference of that inside. Okay? My com wrapper needs a cache wrapper. Okay? Explicitly code that into your wrapper. We'll have a cache wrapper reference inside, and we'll just initialize that. And we'll have the save, the send, whatever was the original singleton functions that were being globally distributed. So now when I get default comms, I say, okay, I got my comms wrapper, go get me the default cache. So before I make my comms, I've got to go get my cache. In my cache, I say, look, I need a default DB. Get me a default DB for this. All right, that doesn't have any dependencies, and I go up and I get the database. The database gets initialized, comes back, drops into the cache gets initialized, drops into the comms get initialized, and we return it back. So we're using features of the language to make the initialization happen in the proper order, and by default, you don't have to think, hey, what secret initializations do I have to do to get this done? It's built for you. And then we go back to my original function just so you can see. To get default comms here, we'll create the comms, create the cache, create the DB, boom, 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 and they all come back and it works. And I still have my dependency injectable main function here. Again, this is all just for dispatching. If someone comes along and says, I'm writing brand new code to use your send data function, Pete, what should I do? It's like, I want you to create a com wrapper, put whatever you need, read them from configs, from your own dependencies, put them in and create it yourself. But all my legacy people, generally they won't budge for me, or they'll say, we're in a much more powerful department than you. You have to dance to our tune, we don't dance to yours, and we're not changing. What can you do? All right, so I want to test this now. All right, this set of singletons that's been replaced. The mock DB client, same as before. The mock cache client, I'm going to inherit from the cache wrapper. I'm going to say, look, make me a When you make me a cache client, I'm going to need a mock DB client. And I'm just going to feed that into the constructor of its inherited class. I'm going to say there's a method. So I have two save methods on here. They're going to take a request, give me back a response. And then on my COM client, I'm going to say, okay, I need a cache wrapper for that. And I'm going to drop that into its inherited base class, because remember, it's insisting it has it. You can't create it without it now. This is how we do it. And then to test it, I just create the clients the same way I would if anyone's using my new function. Create me a DB client, create me a mock cache client, and I'll drop the DB client into it. Create me a COM client, drop the cache client. So we have this long chain of dependencies inside of here now. I take my data record. I'm going to take 3 requests now, because maybe I want to examine each of them at intermediate stages. They don't have to be the same. They can be all different. I just keep them the same so it fits on a slide. And as you see, I set my expectations. I expect the DB client to be called. And once you do, I want you to save it into the DB request. Same for the cache. Same for the comms. And at the end, I can validate values inside all of these requests. I can see that I sent to the database the proper data. If someone makes a change and I do my make test, it's going to fail. I think this is huge as far as getting testability into code bases. And this is part of the reason one project I moved into, they had no unit testing. Like, we can't have unit testing. There's too many hidden dependencies. So we dug a few of them out, and now, you know, people are on board with unit testing because it makes your life easier in the long run. So if we were looking at a graph of length, we also have a graph of width with dependencies. You might think, you know, one singleton per function, that's a limit. No one could go beyond that. But when you actually look inside, there's usually a couple of singletons, right? Someone said, wow, this was really easy. Let me just keep using that to get all kinds of data I don't want to pass directly into the function. When I have multiple singletons and I replace them with these wrappers, I want some natural way of passing them around. So how am I going to do that without a lot of boilerplate? I showed this to a colleague, and he gave me this huge boilerplate of virtual functions and classes and interfaces, and I'm like, there's more code there than I need to write, you know, to do this function for real, like 2 or 3 times over. So let's say the dependency graph now looks like this. I'm in the send data. I have to send something out to people who are listening, save it in the database, update the cache, and maybe send something out in an MQ downstream to some other system. Okay, how am I going to handle that? Well, we can always use brute force. And you've seen functions with 10 or 15 parameters. This is how it happens, right? I have my data function, so I have all the intelligence is in the send data function that takes the 2 parameters. Sorry, now it's 5 parameter function, and this one just dispatches using the defaults. Give me a default of each type, and inject it into the main function where the intelligence actually lives. And in this way, I'll just say for the database, I want to save it, the cache, I want to save it, and I'm going to send it out in the MQ. I'm going to send it out in the comms, I'm going to return the return code. This doesn't look too natural, and this can swamp you over time where people go, oh man, you're sending in 15 singletons into this function. And I've seen 10,000 line functions. So what I'd like to do is just bucket them up in a struct. Right, this is a natural thing. This is what we sort of reach for when we have a bunch of things that are related and we just want to carry them in a bucket. Put them in a struct, say I have a COM wrapper, database, cache, and MQ wrapper. And then I'll just get a default services now instead of each one individually. I'll just take a static services. Creating the services creates me all the underlying wrappers. And I'm going to return that. Anyone see a problem with this? All right. There's actually no dependency injection when I do it this way. All right. I can only drop in a cache wrapper. If I drop in an inherited function, it's just going to call the send wrapper version of the function. Right. Here we go. So I drop in the services now. My send data, instead of doing the brute force calling of all the different wrappers, we'll just call the services. And inside, I'll do my 5,000 lines of data transformation, and I'll call the DB, the cache, the MQ, the comms, and send all this information out. But again, I need dependency injection to do testing. I'm unwilling to do something like this if I lose my ability to test the functions. So this seems the perfect time to use templates. All right. As long as I give it something, that we're templating on a service type, as long as I give it something that has a DB and I can call a save operation on it with a request, I'm golden. As long as I can do the same for cache, the MQ, the services, everything works for me. And again, to help the legacy users out, I just have the get default services. But there is a problem here. This will give me dependency injection, right? I could drop in my mock test class in here, and it will build up the recipe. But there is a problem. The problem with this is, for me to put this template function out where my testing CPP can see it, I would have to turn this into a header file. All right. If any of you have looked at, 1,000, 5,000 line functions, especially in legacy code that are riddled with singletons, you have no shot of making a header-only file. There is file local functions, there's file local variables, there's all kind of nastiness under the hood. There's no way you're going to be able to pull this out. But I do need some way of saying, build me a send data with my mock test class in it. There is a way to do it. It's a little unorthodox. You would have to put a mock service.h file at the top, include it in your production CPP file, which might cause some eyes. I don't know if I got a singleton through. I think I can get this through as well in a code review. It's true. So what am I doing here at the bottom? I'm explicitly instantiating a version of send data with my mock service. So I'm telling the compiler, you don't see it yet, but I need a version of this with a mock service, and that way what will happen is the linker won't complain when I go to build my test. All right. Now, if I'm doing static linking, it'll get dropped out. It won't show up in the production executable anyway. But it is a little non-standard, right? Pulling a test file into your prod code, even if it doesn't show up in your actually linked code. So another way to do it is just group them the same way, but just use it by reference. Okay. Now what happens is, anything that's dropped in there that's a derived class of these wrapper classes will fit in there. And because I have virtual dispatch, it's going to call the right function on my test. It's going to use the test version instead of the base class version. And this is more of a pre-C++ 11 way of doing it. All right. And again, down here, I'll use lazy initialization. I'll just say, hey, create me one of these. If you have problems with your compiler not be able to do the proper double check locking, you just move them as pointers and do it like I showed you in earlier. But really what here is I create one of each and just pass it into my services class and return them back. I now have dependency injection. All right, so as you can see, when I call my services.db.save, it's going to call the reference. The reference can be that class type or any derived type from that class. All right, so how do I mock this stuff out? Again, what I'm going to do is I'm going to take each of these things. They could be have depth or have length, but I'm going to mock them out saying there's a send function that takes the particular signature. Just do it over and over again for all the singletons that are in there. And then I set it up to do it. I'm going to create each one of my my mock clients, and then I'm just going to drop them into to the services. This means now that when these things get called, they're going to do whatever I said, which I've said is copy it into my local variable so I can examine them later. So again, I set all the expectations up for each of these. I say each of these, I want you to save them all into different structures. Once I have that done, I create my test data, which I know what the request parameter should look like. There should be equivalent, there should equal. And then I call the send data function. Inside the send data is going to say services.db.save. That's going to reach into my mock class and just copy that request out to my local variable. So now I can do assertions on the values of all of the singleton, well, sorry, they're not singletons anymore. All of the wrapper data that was passed out, that was passed into the wrappers is now mine to examine. So now I have something that is easily testable and not going to bulk up my function with a bunch of extra parameters. Again, there's a couple of people on the team I'm in, and they really have a thing against virtual functions. They break out in a rash when I give them a virtual function. So here's a way you can do it again using std function, right? If you're in C++11, I'll just say, listen, it's a function. Here we take an int, return a request. These could be all different functions. I'm just keeping them the same for clarity. And then all I do is in my get default services, I'm going to create each one of my wrappers and just give them reference semantics. All right, so we don't fall afoul of that copying rule. And the send data function will change just a bit. Instead of calling a send or a save, I'll just call the parens operator. All right. So we've looked at taking singletons and changing them into wrappers. So people say this is a singleton talk. It's kind of an anti-singleton talk. It's not pro-singleton. So let's say someone has made a business singleton. And they used to have that depending on a bunch of other singletons for whatever reason. So they didn't have to pass these dependencies down through long function chains. I replace them with the wrapper. There's a biz wrapper, a cache, a tcval, a tran. These have dependencies on other singletons. And all I do with them is I say I replace them as well, right? And if I don't want to replace them all, I don't have to. I can use that phased introduction pattern we see. But this way we can handle most any tree of dependencies that were there using the facilities of the language instead of specific knowledge of what's going on. So we now have functions that are testable, right? And where all the, I'll say the globalness is contained into one function, and where the real work is done is now expresses all the dependencies that's needed on it. How are we for time? I have a feeling I'm early. Okay, good. I'm not that early. So let's review. We replaced singletons, got rid of them, while keeping it API source compatible, and in a lot of cases that's probably all you need. It was all that I needed for what I was doing, but then someone said, hey, what if we were shipping a library? We've also seen how to keep it API compatible by using dispatch. How to avoid copies for classes with either deleted or private copy constructors or constructors. How we can delay the initialization of resources. That really is a trick that is also in the regular singleton pattern, so we just had to duplicate that. The big one, I think, is the phased introduction for replacing singleton. In other words, you don't have to do it everywhere all at once, so it becomes a much more bite-sized problem. The initialization order of interdependent singletons, instead of having a bunch of cryptic init calls in your main or someplace else in the code you've farmed it out to, your regular classes will do that for you. And how we group them together again. The grouping was just something someone came in. Hey, I have 2 or 3 singletons. What should I do here? My big thing is we've got testable code now. To me, that's the big win. All right. So if you say, what pattern are you using, Peter, here? My pattern is dependency injection. All right, which is not that new. Right, but what I want to do is bring dependency injection into the legacy code base, which has singletons in it. All right, especially legacy code. So how has it worked out? So the reason I gave this talk was people actually took what was in there and used it. They didn't say, well, that was very interesting, let me go write another singleton. So when I first gave this as a talk internally, it was a much smaller talk. Within a week or two, people were coming up to me, how do I do that again? Can you show me what was going on? And I seen everybody, it was kind of like in a diffuse area around me, started using this pattern, because these were the only people I originally told about it. So the uptake was pretty good. And a little later on, when I was getting ready to come here for this talk, I gave it to a wider audience, and it was a much more expanded talk. And I gave the talk on a Friday, I think it was afternoon. And I got a mail on Monday morning saying, where's the slides for your talk? I said, well, I haven't finished the talk yet, so you're not getting them. And he's like, well, I'm trying to replace a singleton right now. Can you show me some of that stuff you gave me Friday? Right, so people do go out and use this stuff. And, this is the practical part. So, this is one of the pieces I really wanted to hove to, making it testable and practical to replace these things. All right. Now, I've talked to the guy who, had these 150 instances about changing it, and he swears he's going to do this. He just hasn't got around to it yet, so... having people go back into code and change it is a much tougher lift than having them, hey, I'm just about to do something bad. Let me help you out. So this is my email. If you have any follow-on questions after this talk, or you can just walk up and talk to me, or you can email me sometime later. And now we'll take questions. Any questions anywhere? Is there a microphone for someone to talk to?
Thank you. It's probably a bit late for this, but could you talk through slide 11 slowly, please?
Slide 11? I would be happy to. I just got to find it. Okay. All right, so this is close to one of the things I had to use. So instead of just making a wrapper class that was a one use only, I seen where people were using this kind of singleton pattern to contact different services. So I just said, look, the service ID I'm interested in was this one here. It reaches out to a particular service I needed to, but there was other services that needed to be contacted. So I just made it a little more flexible. And in fact, in reality, I could make the send function also a template where the request was also just sent to whoever needed it. I put in a TCP client there because inside of it is a raw socket and you can't copy them. So what happened was when I went to do some of my testing and I made a copy of it, it wouldn't compile. I was like, you're not able to make a copy of this. And so that's replacing the singleton. The second piece is to do with injection of data. So I have clients in production. These clients are unwilling to create a COM wrapper, put in the proper values and make a new API, use my new API. So this thing here is to give me the dependency injection for the people who are using the singleton, who were using a fixed set of values anyhow. All right, they were calling an instance, they weren't able to do anything with it. Does that explain, or you need to know more?
I'll come up later.
All right, someone else here at the front?
Yeah, well, I've seen that you put lots of effort in fixing like static initialization or the hazard, but what about the hazard on distracting data? So suppose a couple of these structures like the database
Could you put the microphone a little
is in a detachable thread.
Could you say that again?
Yeah, so I've seen lots of emphasis on fixing the order of initialization, so the hazard of static initialization. but maybe it's missing a little bit on the hazard of uninitializing. Suppose you have a couple of the structure, like database thing, running in a detachable thread, and another one in another detachable thread. How did you think about how to fix this hazard of? Because at the end, the
Right. Well,
So the order on initialization is properly fixed, but about the order of uninitializing these statics.
you're saying the order of uninitializing.
Uninitializing,
All
yes.
right. So
Suppose
the
you are
singleton
using
pattern doesn't usually uninitialize. They create it, and you can't destroy it.
But suppose you are using it from a detachable thread. You have a logger that is just using a singleton. Your program goes out of scope, but detachable thread is still running. It's still writing the log someplace, and you don't care. You just want it to finish. But it could be that someplace it's still accessing some singleton from your program that just left the main. And
If you're talking about a lifetime issue,
so the hazard of uninitializing the static.
right. So the static doesn't get uninitialized until it's tied to program lifetime. All right. So if you have used a singleton in the beginning, which is what we're replacing, all right, you have an instance of a class that was probably lazy initialized the first time someone grabbed it. No matter what thread you're in, that's the instance you get. There is no instance per thread. You have to be mutexed out. Now, when we replace it with this com wrapper, right, if you're using the 2-parameter function, I expect you to take care of the lifetimes, just like anyone else does. If you have a specific lifetime issue with thread, you could put that wrapper inside a shared pointer, right, to keep it around. You have all this freedom because it's a regular class. I could not do that with a singleton. You've never seen a singleton inside a shared pointer, and if you have, you should go clobber the guy, right? Yeah. Because it's a single instance. So you only have contention to worry about. All right. I don't know if I've explained that. Anyone else? There's someone further down.
Well, thank you for your talk. We sometimes have the problem that we're using singletons from the standard library, like standard chrono, static clock, or file system. And I was wondering, are you always passing in all your dependencies to mock them out, or how do you handle these issues?
So the short answer is you should be passing in all your dependencies, okay? Because when you don't, you can't really test the function. All right. Now, as I have said, in the old days, people, especially when the design patterns book came out, and it was like the singleton pattern, here it is. And when I went looking on the web, half of what I found was here's how to do a singleton properly, right? Was what was there. People used to say it's a this singleton, it's a that singleton. Singleton was used very freely because it gave it a veneer of respectability. I'll say in the last 10 years, 15 years, singletons have gone out of vogue because we've got into testing a lot more. And the singletons make it opaque to test. People don't name them singletons anymore, as you pointed out, right there. Yes, I have my registry, my context factory, my whatever. And like the guy in the Google Clean Code talk when he said, well, when you need a particular doorknob on a door, you don't pass in the color of the doorknob from the very top into the house, and the house puts it into the room, and the room puts it into the door, and the door. He said, no, that's not the way you do it. You have factories. It's like you just ask the door factory for a door, and it has a knob in it. And I said, where'd that knob come from? All right, how do you control what that knob is? And that factory sounds like a singleton. You just named it something else. So, and there are occasions at the very, very top layer of code, usually in the management of code, where you will have something like a registry or, I don't know, callback registry or something like this, where it truly is one instance. And, you know, the testability is like, I'll put something in the registry that calls a test as opposed to the registry being a test itself. So there are places where you will have a single instance of a type. But where people used it a lot was just to make it handy to get their hands on data they didn't want to pass around. And that really was a bad side effect of the singleton. It was so damn handy, And that was the problem. It was so damn handy, people just used it. And, I originally submitted this talk for CPPCon as well. And one of the reviewers sent back, "What's wrong with singletons?" Right? He gave me a 0. He was like, "What's this talk worth? It's worth nothing. What's wrong with singletons? You're defaming it, And another reviewer said, "Hey, singletons are bad. You got to refactor your whole code base. Nothing new here." I'm like, "No, I'm talking about not refactoring your whole code base." Right? That's the point. Because you won't get it. I'm in a project where we are now rewriting an application. And we are 3 years in, and we're just about to start moving the first minimum functionality clients over. So, right, this is results kind of, in a week, let's say. If you want to rewrite your whole code base, it's probably the right thing to do, but it's going to take you years. And the tail of getting all your customers over to that is going to be a lot longer. Anyone else?
First of all, thanks for your talk. I want to share a real-life problem that I wrote a singleton for. So essentially, it was an event processing system. So we get market data feed, and so I wrote a singleton which keeps on updating itself. And I didn't mount the client code, which is the trading algorithm, to have any more states. And whenever it accesses the state, it has the updated value. So in your cases, like I saw, maybe I have missed a certain point, and forgive me for my ignorance. The services and everything is more like once initialized, they are not updating their state.
No. If I have a cache,
Okay.
anytime I write to it, I'm updating it, and I can't. Everyone else has to read from the same cache, which is why I chose that. So for comms, it would not be as big an issue, but for a cache, everyone's got the right to the same cache, right? And that is state by definition.
Yeah, but essentially, so my question essentially next is that, like, how would you prevent someone not creating another cache, and which would have kind of not the updated state?
So if you have 2 caches of data that is not coupled, then that's fine. If they are, your application's not going to work, right? You're going to write it someplace. The other guy is writing data someplace else, and someone has to figure out where it is. So this would be caught, I would hope, in your actual testing, right? Assuming you have testing, and you don't just send it off to QA and say, "Look, you guys find out if I did anything wrong."
Yeah, but essentially, like, so I want to just point out that in this whole example, a cache is you're exposing cache through your libraries. The cache is exposed, so the user can create multiple cache objects independently as well.
Right, and that's a good thing because I can test now. Okay. I can create a new cache, do stuff with it, and throw it away.
Okay, what if I want to ensure, in a scenario, I want to ensure...
All right, we're out of time. If anyone wants to come up and ask me more questions, that's fine. Other than that, thank you for coming.